Hello coders, I welcome you all. In this video, we are going to discuss TF-IDF, term frequency inverse document frequency, which is one of the techniques to convert word into vectors, word into numbers, in short, text into numbers. So as we discussed earlier, techniques like bag of words and bag of n-grams. You can see the bag of words matrix here. It simply counts how many times each word appears in a sentence or document. But there is a small problem. It treats all words the same, giving the same importance to each one. This means every word gets equal weight or value. So common words like the, is, or this get the same value as more meaningful or unique words, even though they don't really carry much information. That's where TF-IDF comes in. It helps by reducing the weight of commonly used words and giving more importance to words that are more specific or informative in a document. Let's take a very simple example to understand TF-IDF. So we have two students, Rahul and Meera, right? So now imagine you are in a college and you meet many people. Let's say you meet Rahul. Rahul is everywhere in all classes, all clubs, all events, and all WhatsApp groups. He talks to everyone. So you can see, because he is so common, he does not help you identify a specific group. So we can say low importance. Let's say you meet another student, Meera. Meera is only in the coding club. So if someone mentions Meera, you instantly know they are talking about the coding club, high importance, right? Now let's connect this to TF-IDF. TF means term frequency, means how often a person or word shows up in a group or document. IDF, inverse document frequency, how rare that person or word is across all groups, all documents. So please remember, a word that appears often in one place but rarely everywhere else is important. I am repeating, a word that appears often in one place but rarely everywhere else is important. Just like a person who is known only in a specific group like Meera helps you understand that group better. This is the exact idea behind TF-IDF. So just keep this example in mind as we move into the technical explanation of TF-IDF. So let's move on. So as we discussed, TF-IDF gives different weights to different words. TF-IDF still counts words, but it gives more value to words that are specific or unique in a document and less value to words that appear everywhere, like Rahul, right? So instead of just looking at how many times a word shows up, it also checks how useful that word is. If a word appears in only one or two documents, it might be important. But if it is in every document, it's probably not that important. Let's take one example. Suppose here we have three documents, document 1, document 2, and document 3. Let's say algorithms, this particular word comes many times in one document, but rare in other documents. That means the word is important for that document. So TF-IDF will give higher weight to that word than to other words in that document. In short, TF-IDF helps us to find which words really matter in the text, not just the common ones that show up everywhere. To calculate this, TF-IDF, it uses two terms, TF, term frequency, and IDF, inverse document frequency. So to find importance of a word for a document, first we calculate TF and then IDF. After that, we multiply TF with IDF to find the final weight or importance of the word. Don't you worry, we will discuss it step by step with proper example. So TF-IDF is different from bag of words because it assigns different weights or importance to each word. That means we give higher weight to words that appear in the document but are rare across all documents. Means rare in the corpus, like Meera, right? As we discussed, this weight or importance is calculated using TF and IDF. So let's start with TF. Please remember, currently we are going to discuss only TF, term frequency. We also call it word frequency. So you can see we have these three documents. Document 1, Python code Python. Document 2, Python code simple. Document 3, algorithms solve problems. Now let's say we have to count TF of the word Python in document 1. So TF of word Python in document 1, this document. So you can see, as we discussed, TF measures how often a word appears in one document. So this is the equation to find TF, number of times word W appears in document D divided by total number of words in document D. So Python appears 2 times, you can see 1 and 2. 2 times in document 1, and there are 3 words in total, 1, 2 and 3. So 2 divided by 3 is equal to 0.667. So the TF value for the word Python in document 1 is this, 0.667. Let's take one more word, simple, this one. So simple appears 1 time in document 2, and there are 3 words in total. So TF is equal to 1 divided by 3, that you can see. Number of times word W appears in document D. Simple appears 1 time in document 2 divided by total number of words in document D, 3 words, 1, 2 and 3. So 1 divided by 3 is equal to 0.333. So TF value for simple in document 2 is 0.333. Here I am taking 3 digits, 667, 333. But you may take 2 as well. So when a word appears more time in a document, the TF is higher, that you can see. So please remember, TF values are between 0 and 1. A high TF means the word appears frequently in the document, and a low TF means it does not appear often, right? Hope all of you are clear with term frequency. But before we move forward, let's compare bag of words with TF only. Please remember, currently we are comparing bag of words with term frequency only, not with TF-IDF, only with TF, right? So when we use bag of words, we just count how many times each word appears in a document, right? Like this. It gives a row word counts. For example, if the word Python appears 2 times in document 1, bag of words will just show 2, that's it. Now term frequency makes the count a bit smarter. Instead of just counting, TF says, let me divide this count by the total number of words in that document. Why? Because it helps balance between long documents with many words with short ones. Please concentrate. A word that appears 2 times in a short document is more important than one that appears 2 times in a very long document. Please concentrate. A word that appears 2 times in a short document is more important than one that appears 2 times in a very long document. So please remember, bag of words is equal to row count of words, where TF is equal to frequency of word, means count divided by total words in document. And as you can see, the table structure looks the same, but values are different. You can see TF values are in decimals like 0.2, 0.6, likewise. If you can see, bag of words values are whole numbers. Hope all of you are clear with term frequency and how it is different from bag of words. Let's move on. Now let's discuss IDF, inverse document frequency. So what it measures? It measures how rare or unique a word is across all documents, across entire corpus. And here is the formula to calculate IDF, inverse document frequency. Log n divided by TF of W. So here n is equal to total number of documents, and df of W is equal to number of documents that contain the word W. Suppose we want to find IDF of the word Python, this one. So it appears in document 1 and document 2, here and here, right? So Python appears in document 1 and document 2. So IDF of Python is log 3 divided by 2. You can see total number of documents, 3 in our case, and number of documents that contains the word W two times in document 1 and document 2. So log 3 divided by 2 is equal to 0.405. So IDF of word Python is this 0.405. Now let's calculate for this particular word algorithms. It appears only in document 3, right? So IDF of algorithms is log total number of documents 3 in our case divided by number of documents that contain the word algorithm, only one. So 3 divided by 1 is equal to 1.099. This is the IDF value for this particular word algorithms. Hope all of you are clear with how to calculate IDF. Previously we calculated TF, right? So IDF is high when word appears in fewer documents. If a word appears in all documents, IDF becomes 0. Let's consider Python appears in all the documents, here, here, and here. We are assuming this, right? Python appears in all the documents. So IDF of Python will become 3 divided by 3, which is equal to log 1 and is equal to 0, right? As I said, if a word appears in all the documents, IDF becomes 0. That means it is not useful for identifying that specific document. So the idea is simple. If a word is common in all documents, IDF is low. If a word is rare, IDF is high. That's all. So here we are giving higher weight to words that are common in one document but rare across all documents, right? So this way we can calculate IDF, inverse document frequency. So if you can see here properly, IDF values are fixed for the whole corpus because IDF measures how rare or unique a word is across all documents, across our entire corpus. But you can see TF is different per document depending on the word's frequency in that document. So TF measures how often a word appears in one document. Hope all of you are clear with this, right? So now we have both TF and IDF values. So we can calculate TF-IDF by multiplying TF with IDF. So as you can see here, TF value for this particular word, Python, in document 1, which is 0.667, and IDF of Python is 0.405. So here is the TF-IDF. So we have to multiply TF with IDF. So this is the TF-IDF value for this particular word, Python, in document 1. Hope all of you are clear with how to calculate TF-IDF. Now let's take a complete example using the same 3 documents. So here are our 3 documents. Document 1, Python code, Python. Document 2, Python code, simple. Document 3, algorithms, solve problems. And here is our vocabulary, all unique words across documents. Python code, simple, algorithms, solve, and problems. So this is our vocabulary. So let's first calculate term frequency for each document. So as you know, TF is equal to number of times word W appears in document D divided by total number of words in document D. Also we can say count divided by document length. So TF value for the Python is 2 divided by 3. Python appears 2 times divided by document length 3. 1, 2, and 3, right? Same for code, 1 divided by 3, this one. For document 1, simple is not there in document 1, so 0. Also for algorithm, also for solve, and also for problems. Now let's move to document 2, and here you can see Python appears once, and we have total 3 words in document 2, so 1 divided by 3. Also same for code, 1 divided by 3. Same for simple, 1 divided by 3. Others are 0. Now let's move to D3. Python 0, code 0, simple 0. Algorithms appears once in document 3 and total words are 3. 1 divided by 3. Same for solve, 1 divided by 3. Here For problems, also 1 divided by 3. Now let's calculate IDF. So as you know, we can calculate IDF like this. Here doc means total number of documents divided by DF, document frequency, right? So here we are adding one extra step before directly calculating IDF. Here we are going to first calculate DF, document frequency, right? So these are terms: Python code, simple, algorithm, solve, and problems. We are just calculating DF. For Python 2, Python appears in two documents, document 1 and document 2. So 2. Same for code. Code appears in document 1 and document 2. So document frequency is 2. For simple, 1. Algorithms 1. Solve 1. Problems 1. Now from this we can easily calculate IDF. Doc divided by DF. Total we have 3 documents. So log 3 divided by 2. Log 3 divided by 2 for code. For simple, log 3 divided by 1. We have 3 documents and document frequency is 1 for this particular word, simple. Log 3 divided by 1 for algorithms. Log 3 divided by 1 for solve. Log 3 divided by 1 for problems. And these are the proper values. 2 divided by 3 is equal to 0.667. 1 divided by 3 is equal to 0.333. Log 3 divided by 2 is equal to 0.405. And log 3 divided by 1 is equal to 1.099. So now let's replace the fraction with these values that I have done over here. Right? Here I have replaced the fractions with these decimal values. And for IDF as well. So we have replaced the fractions with these decimal values, right? These values here and these values here. So now, as you can see, we have TF values and IDF values. So we can calculate TF-IDF by multiplying them. Let's do this. Let's find TF-IDF. So this is TF value for Python in document 1, for code, and all others are 0 for document 2. This is the TF value for this particular word, Python, and for others. Same for document 3 as well. So here we have TF values that we already calculated. And here we have IDF values. So now let's multiply TF with IDF to find TF-IDF, term frequency inverse document frequency. So let's multiply IDF values. Done. So if you can see here, we don't multiply where TF is 0 like this, because the result will be 0 anyway, right? So now we get the final TF-IDF matrix for our data set. This one. So this is our final TF-IDF matrix for our data set. So if you can observe properly, Python and code appear in both document 1 and document 2. So lower TF-IDF value, lower weight. But as you can see, simple, algorithms, solve, and problems are unique. So higher TF-IDF values that you can see. So this way TF-IDF helps us to highlight important, means rare terms in each document while ignoring common ones that you can see here. Hope all of you are clear with TF-IDF, term frequency inverse document frequency. So let's move on. Now let's discuss advantages of TF-IDF. First, simplicity. It's easy to understand and implement. Just uses counts and logs. Next, effectiveness. Works well for traditional document retrieval, keyword extraction, and text classification. Next, highlights important words. It gives higher weight to words that are frequent in one document but rare across all documents. Please recall Rahul and Meera, right? Next, good baseline. Often used as a solid starting point in NLP before trying more advanced models like word embeddings or transformers. Next, no training needed. Unlike neural models, TF-IDF doesn't require training. It's purely statistical. Now, here are some drawbacks of TF-IDF. First, it ignores word order. It treats text as bag of words and ignores grammar, sequence, or context. Next, No semantic understanding. It does not capture the meaning of words. For TF-IDF, car and automobile are treated as unrelated. Next, sparse representation. It produces large sparse matrix with many zeros, right? Especially for large vocabularies can consume a lot of memory. Domain sensitive. IDF values are dataset dependent. Adding or removing documents can change scores significantly. Static vocabulary. Here also the problem of OOV, out of vocabulary. Once the TF-IDF is computed, new unseen words or documents can't be easily integrated. Means unseen words are ignored without recomputing everything. So these are some of the advantages and drawbacks of TF-IDF. So now here one of the important question is, why do we take log in IDF but not in TF? So as we already discussed, TF is like probability. The value of TF lies between 0 and 1. But now let's take an example. Suppose one word appears in only one document and we have total of 1000 documents. So IDF becomes 1000 divided by 1. Here we are not considering log, right? So IDF is equal to 1000. Now if we multiply this with TF, which lies between 0 and 1, the IDF completely dominates the TF and we lose the effect of TF. So to avoid that, we apply log on the IDF value. This reduces its scale and brings it closer to the TF range, right? So here if we take log, so value becomes 0.69. Now this is much more balanced with the TF score. It is not like extreme high like 1000. So that's why we are taking log in IDF. Hope all of you are clear with this, right? Why we take log in IDF. Let's move on. As you can see, currently I am searching TF-IDF sklearn because I want to show you our calculation of IDF is different than sklearn. Let's press enter and let's click over here and here. So they add 1 after taking the log, that you can see, and here as well. If this particular parameter of TF-IDF is equal to true, sklearn will use this equation to calculate IDF. If it is false, then sklearn will use this particular equation. But default equation of IDF is this for sklearn. Here you can see it is adding 1 here as well and also at the end. So here +1 in both numerator and denominator is used to avoid division by 0. So that's why a technique called smoothing. And final +1 is added to ensure IDF is never 0, even if a term appears in every document. So why this one is at the end? Please remember, the reason is simple. Imagine a word that appears in all documents. So IDF will become 0, but in reality, the word is still present. So sklearn says, let's not assign 0 weight. Let's at least give it some importance. That's why they add 1 after the log at the end. So such words still have a small non-zero weight. Hope all of you are clear with this, right? So our manually calculated answer of TF-IDF matrix is different from if we calculate with sklearn because they are using this particular equation, right? That I will show you practically shortly. So let's jump to practical part. First, let's import TF-IDF from sklearn.feature_extraction.text. We have to import TF-IDF vectorizer. Let's execute this cell. Now let's create our documents. Same Python code, Python code, simple algorithms, solve problems. Done. Let's execute this cell. So now we have these 3 documents, document 1, document 2 and document 3. Now let's create instance of TF-IDF vectorizer. So TF-IDF vectorizer and let's create instance with name vec. Now vec dot fit underscore transform, and here we have to provide our documents, this one, and let's assign it to TF-IDF underscore matrix is equal to this statement. Let's execute this cell. Done. First, let's check features, our vocabulary that you can see here. Assign it to voc. So to visualize TF-IDF matrix, we have to convert it into array, and let's assign it to TF-IDF underscore array is equal to this statement. Let's execute this cell. Let's check. You can see here. Now let's display TF-IDF matrix nicely. So for that, we have to import pandas as PD. Create pandas data frame so we can visualize TF-IDF matrix properly. So here we have to pass this array, and let's set columns is equal to this, our features. Done. Let's execute this cell. Great. That you can see here, our TF-IDF matrix for our documents that you can see. And if you compare it with our manually calculated matrix, as I said, it is different because sklearn adds 1, right? Now you know this. Also, we can convert it into 3 decimal points. For that, let's assign it to df and sprint df dot round 3. Let's execute this cell. Done. So this is our final TF-IDF matrix. I hope all of you are clear with TF-IDF. It helps by reducing the weight of commonly used words and giving more importance to words that are more specific or informative in a document. I hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.